So I don't know how many of you call me, but my mobile is in silent mode. There are many calls while I'm in the class. But it is, sorry for that. It's tough to address while I'm in the class. I cannot focus on the call at the same time WhatsApp and all. Don't mind. And now come to last session. Where were in the last part? Modeling theory, right? Oh. What is data modeling? Modeling the data. What do you mean by modeling the data? Establishing relationship between the data. Establishing relationship between data. Why we need to establish? Accurate data. Second one, in case of multiple sources you want to combine and use, again you require multiple sources you want to combine and use, again you require proper relationships. Proper relationships. This is what is data model, need of proper data model, basic advantage of data modeling. And usually companies level, 4 types of model: business process, conceptual, logical, physical. And this is a terminology we use in all the models. Entity, table or row. Relationship, table to table, row to row relationship. Column, attribute. Column type, data type. Primary key, no null, no duplicate. Foreign key. One table primary key value, if you are using the second table, then it is a foreign key, but conditions apply. The condition is parent table values to be taken in the child, then only foreign key. If parent values you're not taking in the child, no foreign key, no foreign key. And conceptual level, this is the terminology we use. Logical level, this is the terminology we use. Physical level, this all terminology we use. Physical level. So you may get in the real time. So not real time. You may be asked by your manager, Razu, could you please look at the physical model and verify the Power BI reporting data? Physical model. So physical model means the model which has table, column, data type, relationship, etc. Physical. If your customer says, Raju, I given logical model, could you please verify the logical model with our reporting? A little bit tough to verify reporting with a logical model, because full-fledged objects, full-fledged columns, data types, keys not available in the logical model, so you cannot ensure a proper report in the physical level. Sorry, in the report level. Logical is logical, physical is physical. So compulsory. If your experience crosses 3 years, they will give you physical model, logical model, different types of model, and ask you to work on it. Now conceptual model. So business objects existed here. Take a banking organization, savings account a concept, current account is a concept, and demat account is a concept. Concept, specific operation. That model. Even one more realistic example I told you. Venture, real estate organization, venture. That particular venture having 3 towers, each tower having some floors. So the towers is the concept. Tower 1, tower 2, tower 3. The all together the venture model. Now logical model. It's a detailed version of the conceptual model. very detailed version. So what are the tables required and how the table should be connected? That high level relationship possible only in the conceptual model, logical model. Tables and high level. Could you please read these two lines? First line, second line. Please read it. So this is talking about, do you know how to read a logical diagram? Supplier table columns like this.
ఏ కర్రీ వేసి పంపియే ఏ బాబు ఏ కొద్దిగా వేసి పంపియు పన్నీర్
Not exactly columns. Customer table, proposed columns. Order table, proposed columns. And what about this? One. What about this? Many. Which means one supplier may supply multiple products. Other words, supplier table, supplier ID unique, product table, supplier IDs, duplicates. Supplier table, supplier ID unique, product table, supplier IDs, duplicates. Because one to many, multiple. Examples like this: P1 product from supplier 1, P2 product also from supplier 2, P3 product also from supplier 3. That's it. This is one to many. But here supplier table level, supplier IDs are unique. Supplier 1, supplier 2. Sorry, I'm wrong. Supplier 1. Same supplier, 3 products. But here S1, S2, S3 all are unique. All are unique. So what do you mean by this? This meaning one customer, multiple orders. And what is the meaning of this? Multiple orders and multiple products. This is logical diagram, logical data model. Any questions? Any questions? but this is not good enough. This is just logical picture. You may contact these people, you may contact these people, something like this, logical. But it comes to physical like this. What is physical model? Actual design, blueprint of relational database. Blueprint of relational database. Come down, see this. A supplier table, ID, name, contact. Supplier table, ID, name, contact. So this is the primary key because unique. Supplier ID is unique and details unique, primary key. So one. So wherever one available, there we take primary key. One indicate cardinality. Cardinality one. What is cardinality? That is granularity. పర్లేదు మంచిగానే కవర్ చేశారు. Granularity, level of data. Cardinality, how many times the value available. So cardinality 1 means it is one time available. One time available, cardinality 1. So supplier table cardinality 1 means supplier ID one time available. And here cardinality many. Many means so this to this only. And this is foreign key. Many. That means multiple times the same supplier ID available. In supplier table, supplier ID unique. This is the product table, product ID is unique. What is unique? Supplier ID foreign key. What about customer table? Customer ID unique. Purchase order table, purchase order ID unique. But this is a foreign key. That means one customer, multiple orders. Now multiple orders, multiple products, multiple orders, sorry, multiple products, multiple orders. So if you want to implement multiple product, multiple order, compulsory intermediate table is required. This can also be called bridge table, or central table, or any table with multiple foreign keys. Multiple foreign keys. Example, this is bride team, bridegroom team. Both want to communicate with each other. How do they communicate? Using a central marriage bureau or consultancy. So this person will have bride number, this person will have bridegroom number, and he will only provide communication between them. Yeah, you can say broker, marriage broker, or anything. This person will have contacts of the both the people. Depending on the situation, he will share. He will provide communication between them. So products are different, orders are different. How they will communicate with each other? By using a single central table. And this is many to many. In other words, wherever many to many required, there you require single central table. Single central table. And this is a measure. Which support aggregate operations. Which support analytical operations. Aggregate analytical operations. And we also call this table as factor table. What type of table? Because foreign key is available, measure available. And here only textual values available. So we call it as a dimension table. Because of functionality, I'm calling dimension. Textual value, no aggregate operations, so dimension. Textual value, no aggregate operations, so dimension. And these textual references in this area. So this is a fact table or bridge table. What type of table? Fact table or bridge table. Shall I? So this is about logical. This is about physical. So this logical directly not possible. So we go for physical.
So, sir, in real time, we have to work on physical data or the logical data?
Always physical data is required. This is the one. So this kind of model only required, guys, before you work in the real time. Right. So who will develop, sir, all these models? In the organization, modelers, designers, architects, those people develop business process model, conceptual model, logical model, all the models. Even the junior designer, junior architects, they'll work in the physical model. And a senior developer will work in the physical model. Senior developer work in the physical model. Even administrators, they will also work in the physical model. Because if the logical model is ready, almost physical model we can make it. Almost physical model we can make. But for these three models, good modelers, designers, architects required. Even here also their presence is there. We can't say. But practical creation of the tables and all anybody can do. Mostly this part operated by modeler, designer, architects. But creation, practical creation of table relationships can be done by a senior developer, can be done an administrator, can be done by junior team. Junior team. Got the point clearly? That's it. Right. Now come to some important terminology. What is entity? Tuple, columns are row, attribute, column, primary key, which take only unique values. Foreign key, one place it is unique, another place it is normal, then is foreign key. Dimension, textual attribute does not support aggregates. Fact, measurable attribute support aggregates. And if you take 100,000, 2,000, 300, they never support aggregate. We never use aggregations. We never use for aggregations. So dimension. Sales ID, all the number, but we don't use for aggregate operations. So it's called as a dimension. Sales income, number and support aggregate operations, not sales number, sales income. So ID is a number, but we don't use for some average or dimension. Income is a number which is used for aggregate operations, so measure or fact. Any point, anyone having doubt? అర్థమవుతుందా? టపుల్ డాటా టైప్ కాదు, కలెక్షన్ ఆఫ్ కాలమ్స్ ఉంటే దాన్ని టపుల్ అంటాం. స్టూడెంట్ ఐడి, స్టూడెంట్ నేమ్, లొకేషన్, ఇలా కాంబినేషన్ కాలమ్స్ ఉంటే టపుల్ అంటాం. మరి కొంతమంది రో అని కూడా అనొచ్చు రో. Now here see this set of dimensions connected to fact table. So this is a star schema, and also fact table containing two sections. One is foreign key section, second one measurable section. Foreign key section, measurable section. And what do you call this? Fact table surrounded by dimension. Dimension contain hierarchy, snowflake schema. Now, what is dimension table? textual attribute table, and contains set of textual attributes. And it is a master table, contain primary key. Surrogate key is highly supported. What is surrogate key? I will tell you in few minutes. Support hierarchies because take location table, country, state, district available. It is supporting hierarchies. So dimension table. Take a date table. Date table contain year, quarter, month, etc. We can also establish. So you can also create hierarchies. Quarter, sorry, year, semester, quarter, month, etc. So that is a hierarchy and support in dimension, date dimension. Only dimension table support hierarchies and dimension table data is less. Dimension table level more columns available. Dimension table support for these kind of textual questions answers. And dimension tables are rarely changed tables. Rarely changed tables. Rarely or slowly change data tables. Dimension tables. Coming to fact table. Fact is a measurable attribute. Set of measures available area, fact table or measure group table. Many relationship provided. It contains two sections. One is foreign key, measures. So many times I repeated the same part, right? It is a child table, a transaction table, or operation table, or business analysis table. Fact table contains foreign keys and measures. What is surrogate key? I will explain you in few minutes. It does not support hierarchies because measurable data more and more it will not support hierarchy. And more number of records available when compared to dimension table. Less columns available and more rows available. Answers for aggregate analytical questions. So these are all analytical questions. And what do you mean by aggregate? Sum, average, max, etc. These are aggregate. And frequently changed data table is fact table. Daily data loaded to fact. Next one, difference between dimension and fact table. Could you please read once? Dimension table contain primary key, fact table contain. Next, whole textual values. Here, measurable values. No measurable information does not support for aggregate storage. Aggregate analytical columns, more. More columns, less columns. Maintain less rows, more rows. Support hierarchy, no support. Drill down, drill up possible, not supported. Answer for these questions, answer for this. Rarely change or slowly change the tables. And here it is different. Shall I? At any point you have doubt? No doubt. Sure.
So, sir, I have a question. So you are saying like foreign key can be the primary key, right?
No. Foreign key is a key which will take values of primary key of another table.
Okay, like unique key.
Yes,
unique ID, right?
correct.
And it can be also used as foreign key also in for another table, right?
Yes, yes.
Oh,
Next, types of dimensions. From now, I will explain little more because dimension table, fact table, what difference between dimension and fact table at the beginning of our classes also explained. If I explain again and again, even I feel very bored. Whatever the new part is there, I will explain in detail. So types of dimensions, this is important. Not covered, correct? Is it covered? No. So fact tables surrounded by different types of dimensions. And those dimensions types I'm going to explain now. See, this is one sales and shipping business in model, sales and shipping model. For our comfortness, I took only limited tables. Take Amazon, Flipkart, Snapdeal, same business. When you purchase a product, the product value available here, sale. If it has to be delivered, the delivery information available here. So same product, whatever you purchase, that will be delivered. So both the tables contain this table column values. And this kind of tables are called confirmed dimension table. What type of table? So the dimensions which are shareable are called as confirmed dimension tables. In this situation, product table is a confirmed dimension table. Whatever you purchase, the same to be delivered. So this is called as a confirmed dimension. Right. Now take date table. Your company working for 320 days out of 360. Not all the days, 320 days out of 360. So your order date, your delivery date, your due date, everything should be one of the date in the 360. One of the date in the 360, isn't it? It should be. Otherwise, customers fight with the organization. Customers fight with the organization. So your working days are 320. So the date should be one of the date in the 320. How do you make it? So take 3 foreign keys on this column. How many foreign keys? 3. So this kind of dimension table is called role-playing table. What type of table? Role. So the dimension table which is giving multiple foreign keys is called as the role-playing dimension. Sir, 3 foreign keys, okay, but how many will be active? At a time, only 1 foreign key active. How many? Only 1. Only 1 foreign key active. For example, due date is active, remaining 2 inactive. Ship date active, remaining inactive. Remaining at a time, only 1 active, not all active. Sir, can I make others active? Why not? Yeah, active one make it inactive, so that inactive one you can make it active. Active one make it down, so inactive one make it up. It is a simple process. That is called active inactive relationship and active inactive relationship management. Inactive relationship management. So compulsory we use in the real time. So one dimension table, multiple foreign keys you need in the fact table level, you can take it. And such kind of dimensions are called role-playing dimension. Role-playing dimension. One will be active, remaining will be inactive. Next, this is a fact table containing how many columns? 2 types of columns. One is foreign key, second one measure, normal. So product ID, foreign key, amount. This is amount. So the amount is a measure. And other than this, if you contain columns, if you maintain columns like this, shipping number. So what do you call this? This is not a dimension. Product ID is a dimension, and this is not a measure. So these kind of columns are called degenerated columns. What do you call it? Degenerated columns. So the columns which are in the fact table, but they are not from a dimension, At the same time, we don't use it for aggregate analytical operations. So we call those columns as degenerated dimension columns. Degenerated. You can ask me, why don't we call degenerated fact? Degenerated fact is wrong. Degenerated dimension is correct. So could you please read what are types of dimensions available? Hello. Hello. Is it okay? Any doubts? Next, dirty dimension. We don't use this, so don't worry. Then we will go to junk dimension. If a dimension has non-business data, no need to have a dimension always business data like location data, product data, supplier data, order data, etc. Sometimes the dimension may have flags. Sometimes dimension may have indicators. Sometimes the dimension may have codes, code values. And those dimensions are called junk dimensions. Take a gender table, M for male, F for female, T for transgender. What kind of business it is doing? It's not doing any. So we call the dimension as junk dimension. Assume there is a dimension table, country, currency code, India, rupees, Singapore, Singapore dollar. What type of business it is doing? Nothing. So those tables are called as junk dimension tables. In this situation, if you see this product table, date table, all the tables are proper dimensions, but this is not a proper dimension. That is called junk dimension. Madam, clear? Next, if you are an ETL developer, data extraction, transformation, loading developer, SSIS you are working on, SSIS, Azure Data Factory you are working on. In that situation, a rapidly changing dimension, slowly changing dimension, info dimension, shrunken dimension, these all dimensions you need to focus. In case you are a ETL developer, data extraction, transformation, loading developer, then you should focus on all this. If you're a reporting developer, majorly you need to focus. Majorly you need to focus confirm dimension, junk dimension, designer dimension, and role-playing dimension. So what is confirm dimension? It can be shareable. What is junk dimension? Other than business data and containing flags, indicators, etc. Role-playing dimension, dimension which has multiple foreign keys. Degenerated, same table level, sorry, fact table level, the column available, neither dimension nor fact. Neither dimension nor fact. Next, types of facts or measures. What is the first one? Fully iterative. So I'm explaining now. Within the fact table, you have multiple measure columns, correct? Actual fee, discount fee, tax amount, like this multiple columns. There are how many types of columns you can maintain? That are two measurable columns. How many types of measurable columns you can maintain? First one, fully iterative. Fully iterative means the column support full aggregation, sum, average, count, etc. Fully it will support. Semi-iterative. Semi-iterative means the column support partial aggregation. top, bottom, first, last, etc. Not all participating, only few participating, only few. Non-additive. You have last year data, already calculate data, current year data, calculate data. You want to find out growth. You want to find out growth percentage. For that, no need to go to any dimension table. By using existing measures, you can create one more measure to perform calculation. And those measures are called non-additive measures. Non-additive. Once again, I'm explaining. Fully additive measure indicate the measure which support full aggregation, the measure which is contacting multiple dimensions or all dimensions. Semi-additive, the measure with partial aggregation, the measure contacting few dimensions. Non-additive, it will not contact any dimensions. Already measures are available. From there, one more measure you will create. Without contacting dimensions, you are creating one more measure. Maybe aggregate, maybe non-aggregate. Those are called as non-additive measures. So fact table level, you find three types of columns: fully additive, semi-additive, non-additive. Go through it.
So sir, if a column has like true, false, so it comes under,
Pardon?
if column has true or false.
True or false?
Yeah.
No, fact table level, why you will maintain true, false here? I'm talking about measures. Do you think a measure contains true, false value?
So it comes in dimensions.
Yeah, it could be dimension. True, false, then it is an indication. So junk dimensions.
Okay, jump. Yeah.
I'm talking about these measures: revenue, quantity, etc. So you understood this. And next one is types of fact table. So dimension, surrounding dimension types I explain. It could be junk, it could be G-generated, it could be role playing, it could be confirmed, it could be anything. And within the fact table, the measurable types I explain. Now fact table types I'm explaining. What type of data fact table may hold? What type of data fact table may hold? Dimension table data, you know very well. Textual data, mostly static data, rarely changed data. But fact table continuously changing. What type of data it can hold? First one, snapshot data. Snapshot means at a particular point of time, at a particular instance, you want to say a particular instant data, a particular point of time data. If you maintain in the fact table, there is snapshot fact table. Example, 2019 data only I required in the fact table. Hyderabad location data only I required in the fact table. Chennai and Bangalore data only required in the fact table. Then go for snapshot. Cumulative means different. Already fact table having some rows. Fact table having some rows. You want to add more rows. And daily record, daily loaded data you want to move. A daily business data you want to move. That is cumulative fact table. Cumulative. So historical tables or incremental tables, those can also be called cumulative tables. Those can also be called as cumulative. History table, daily data is coming and moving into it. Daily data coming, moving it. So automatically cumulative table, cumulative data table. So fact table may hold an instant data. Fact table may hold cumulative data. What type of data? Cumulative. And the fact table could be factless. What is factless? It will not contain any facts. It will not contain any measures. And those tables are called factless fact tables. What do we call it? Factless. Sir, can you give me an example? Very simple. Factless fact tables talk about recording an event, covering an event. They will cover an event, they will record an event, but they will not participate in the measure analysis. They will not participate in the measure analysis. See this. You guys are daily coming to the institution to learn something, to gain some knowledge. Your data, you can keep it like a event covering, a recording event. Day to so and so, day to so and so course, so and so student to so and so professor, so and so room. You can maintain all. But what type of measurable data you can keep? What type of measurable data you can keep? If you purchase a product, there is a purchase value. If you sell a product, there is a sale value. But what about class? You're attending a class. What type of business value it can maintain? Come on, guys. What kind of business value? In this 1 hour, how much you understood I want to place? How much you gain I want to place? Is it possible? మీరు ఈ హాఫ్ అన్ అవర్లో ఈ 1 అవర్లో ఎంత అర్థం చేసుకున్నారో నేను ఇక్కడ ప్లేస్ చేయాలి. పాసిబిలిటీ ఉందా? ఉందా? Not possible. We cannot. Our technology not developed that much level. So, but still you can cover an event. So candidate today attended the class. So these kind of coverage tables or recording event tables are called as factless fact tables. What do we call it? Factless fact tables. Can I? So total, how many types of fact tables available? 3. Snapshot, cumulative, factless fact. And what is the next concept? Somewhere we heard about surrogate key. Where? Even in our practicals also we discussed the surrogate key. Okay. The word surrogacy is very popular in the market. Baby somebody else's womb. The same thing here. You have a table. The table level uniqueness you are not able to find out properly. Then we take one extra column, that to sequential column, and automated values by the system, and non-changeable values by the system. And those columns are called surrogate key columns. Which columns? Already you have a table, but you are feeling difficult to identify records uniquely. Then we take one extra uniqueness column, but it's not a business column. The extra uniqueness column does not contain duplicates, does not support changes. And those columns are called surrogate key columns. What do we call it? Surrogate. Extra business key columns. Example, look at this. Street number, street name, city, state, zip code, modified date. Tell me which column is unique here. You can't take, no, don't go for this. And the street number, it is a valid street number, but it can't be unique. Multiple cities may have same street number. How come you take unique? Now street name, Gandhi Nagar. Almost all towns and cities having Gandhi Nagar, can't be unique. And state, same state, multiple cities may be available. How come it is unique? Same zip code, multiple street number may be available. How come it is unique? Modified date also. Same date, multiple locations may be modified. How come it is unique? But this combination is unique. 123 street number with this name in the city available. In the city, no street name with the same number. And the state, the zip code, this modified date. This complete combination is unique. So if you want to recognize the record uniquely, complete combination you need to write. Then only you will feel it unique. But don't you feel complex? In the situation, we take one extra column, non-business key column, non-related column, that is surrogate key. Take address ID. 1, 2, 3 and all. 1 indicate this record, 2 indicate this record, 3 indicate this record. Now this is unique. But it is not a business value. It will not fall under straight information or any information. One, what type of information it is? Nothing. So non-business key uniqueness value column used to recognize records uniquely. Those kind of extra uniqueness columns which we add to the projects are called as surrogate keys. What do we call it? Some people also call it as a business intelligence key. Some people also call it as a data warehouse key. So the name may changes, but ultimately functionality, extra uniqueness column with system defined values, non-changeable values to recognize records unique. This is single table. Okay, you understood. I'll tell you multi-table example. So this is a dimension table, salesperson dimension. Here customers data changing. Customers data changing because customer person data, right? Personal data changing. So JONL, James O'Neill, North Territory currently available. SVLM, Steve Lem, East Territory not available. SVLM, this is a customer, Southwest Territory currently available. This is a dimension table, and we don't take these kind of historical dimension tables primary key. We never take primary key on this kind of historical tables. If you take primary key on this, no history. How come you take SVLM second time? No history. So mostly we use one word in the history tables, business key. What is the column? Business key means the JONL indicate this name only. SVLM indicate this name only. It can't be other names. It can't be other names. Such kind of business keys terminology we use in the warehousing projects, but we don't use primary key terminology. Okay. Now the concept. Steve Lamb, when he is in East Territory, he purchased something or he sold something. How do you mention that in the fact table? You know very well, fact table contain dimension reference. So which one you will take? For example, if you take this in the fact table level, confuse. East business or Southwest business? Right or wrong? అర్థమవుతుందని చెప్పేది? When you place this record in the fact table, SVLM, confuse. East business or Southwest business? Okay, you will add this East also. But available or not available, you need to add this also. If we add like multiple columns in the fact table looks very complex. Number of columns also more and more in the fact table. Ultimately, performance will go down. In this situation, to recognize each record uniquely in the dimension table, we take extra non-business key column value, that is surrogate key value. This is a surrogate key value. Work 1, 2, 3. 1 indicates JONL, 2 indicates Steve Lamb East, 3 indicate SVLM Southwest. SVLM. Now you take this 2 indicate, so 2 some business that indicate, oh, Steve Lamb East. 3, okay, 3 Steve Lamb Southwest. This is the business he did. This is the concept of it. This is the concept. So if dimension table of history available and you want to recognize records uniquely, we go for surrogate key. And you want to read for a moment, yes, read it. Please read these points.
A surrogate key means it is not unique, sir. That means not unique.
Surrogate key is always unique.
In this table, we considered that 1, 1, 2, 2, 2, 2, same.
No, I'll show you, sir. This is surrogate key. It is unique, but this foreign key only we take in the fact table, right?
Okay,
The
sir.
fact table may be duplicate. This is a foreign key. Now the surrogate key is a foreign key, and this is primary key.
Okay, sir. Okay. So in the dimensional table, it is surrogate key. In the
Dimensional table level, it is a surrogate key.
surrogate
It acts like a primary key,
table. Okay, sir.
and we take in the foreign key level.
Okay, sir.
Excellent. I want to read one more, please. If you have very good knowledge on this. Shall I? ER modeling, entity relationship modeling. You know very well. Entity, tabular, or primary key. What is primary key? unique, not null, foreign key, one table uniqueness value, one table uniqueness value. If you take in another table, then it is a foreign. What is relationship between two entities? Relationship. Cardinality, possible number of times appearing. One time, then one, two times, then many. So these are the three cardinalities available: one to one, one to many, many to many. So the ER model relationships are three types: one to one, one to many, many to many. One to one means first table, the relationship column having unique value. Second table, the relationship column having unique value. And one to many means first table, the relationship column unique. Second table level, many. For first table level, many times. Second table level, many times available. So one to one best example. Student to student profile. One student, one profile, one to one. That means student ID here one time available, student ID here one time available. That is one to one. So you can call in second way like this: one profile, one student, meaning no changes. One student, one profile, one profile, one student, meaning no changes. That's why single or bidirection, same meaning. No intermediate table also required. So one to one level, no intermediate table required. Next, one to many. One student can join multiple courses. So one student ID 1, 2, 3, let us assume. The student ID 1 join MSBA, student ID 1 join Power BI, student ID 1 join Azure. That is one to many. Student ID one time available, student ID many times available. But reverse meaning is wrong. So single and bidirectional are different. No intermediate table. One to many. Now many to many. Here student ID, course ID. Student ID 1, 2, 3 available. Course ID MSBA, Power BI, Azure available. But any student, any course. So one MSBA, one Power BI, two MSBA, two Azure BA, like this. Any student, any course. That relationship possible only in the intermediate area. That is many to many area. Which area? Many to many. Understood this? I think many times I explained this. So here single bidirectional different relationships different. Compulsory bridge table required. What is the table required? Bridge table. So these are the different relationships. So how many types of ER modeling relationships available? Three types. What are the types? One to one, one to many, many to many. In which situation we require intermediate table or bridge table? So many to many situation, you require intermediate table or bridge table. Done.